Hello friends, welcome to this YouTube channel. Today we are going to solve a couple of simple numerical problems on basic concepts of electrical engineering. By solving these problems, we shall learn how to determine the amount of energy in context to an electrical system and estimate the cost of energy. Electric power is defined as the rate of change of electric energy, P equals to W by T, where W is the electric energy. It is defined as the capacity of doing work. W equals to P into T. The voltage between any 2 points in an electric circuit is defined as the work done in moving unit charge from the point of lower potential to the point of higher potential. Therefore, W equals to V into Q and P equals to V into Q by T. Electric current is the rate of flow of charge with time. I equals to Q by T. Therefore, P equals to V into I. According to Ohm's law, V equals to R into I. Therefore, P equals to I square R or V square by R. For rotating machines, P equals to Td into 2 pi n by 6t, where Td is the torque exerted by the rotor in Newton meters and n is the speed of the motor in revolutions per minute. Electric power is measured in watts. To measure larger power, we use kilowatts. 1 kilowatt equals to 1000 watts. Electric energy is measured in kilowatt hours. 1 kilowatt hour is termed as 1 unit. If electric charge per unit equals to rupees X, cost of electric energy equals to rupees X into W. A microwave oven of 1500 watt is operating with 230 volt AC supply. We have to calculate the current rating of this oven and the cost of energy for 3 hours operation when the electric energy costs rupees 4 per kilowatt hour. Let us first write down the given data. Power rating of the oven P equals to 1500 watts. Supply voltage V equals to 230 volts. Operating time T equals to 3 hours. Energy cost per kilowatt hour equals to rupees 4. Assuming unity power factor, let us determine current rating of the oven. I equals to P divided by V. Using values we get 1500 divided by 230, that is equal to 6.52 ampere. Electric energy used by the oven W equals to P into T. Using values we get 1500 into 3, that is equal to 4500 watt hours or 4.5 kilowatt hour. Cost of electric energy equals to rupees 4 into 4.5, that is equal to rupees 18. The power rating of a 29-inch color television is 80 watts. The TV is operating with 220 volt AC supply. We have to calculate the current rating of the TV. Also, the cost of electric energy to operate this TV for 18 hours when the electric energy costs rupees 5 per kilowatt hour. Let us first write down the given data. Power rating of the TV P equals to 80 watts. Supply voltage V equals to 220 volts. Operating time T equals to 18 hours. Energy cost per kilowatt hour equals to rupees 5. Assuming unity power factor, let us calculate current rating of the TV. I equals to P divided by V. Using values we get 80 divided by 220, that is equal to 0.3636 ampere. Electric energy used by the TV W equals to P into T. Using values we get 80 into 18, that is equal to 1440 watt hours or 1.44 kilowatt hour. Cost of electric energy equals to rupees 5 into 1.44, that is equal to rupees 7.20. The power rating of a DVD player is 4600 watts. The player is operating with 220-volt AC supply. We have to determine the current rating of the player and the cost of electric energy to operate this player for 5 hours when the electric energy costs rupees 5 per kilowatt hour. Let us first write down the given data. Power rating of the DVD player P equals to 4600 watts. Supply voltage V equals to 220 volts. Operating time T equals to 5 hours. Energy cost per kilowatt hour equals to rupees 5. Assuming unity power factor we get current rating of the DVD player I equals to P divided by V. Using values we get 4600 divided by 220, that is equal to 20.91 ampere. Electric energy used by the DVD player W equals to P into T. Using values we get 4600 into 5, that is equal to 23,000 watt hours or 23 kilowatt hours. Cost of electric energy equals to rupees 5 into 23, that gives us rupees 115. A 2 kilowatt motor, a 500 watt heater and a 750 watt electric iron are all operating at the same time on 230 volt line. We have to determine the cost of operating all the equipments for 4 hours when the electric energy costs rupees 4.50 per unit. Let us first write down the given data. Power rating of the motor P1 equals to 2 kilowatts, that is equal to 2000 watts. Power rating of the heater P2 equals to 500 watts and power rating of the electric iron P3 equals to 750 watts. Operating time T equals to 4 hours. Given energy cost per unit equals to rupees 4.50. Let us first calculate total load. P equals to P1 plus P2 plus P3. Using values we get 2000 plus 500 plus 750, that is equal to 3250 watts. Now we shall calculate total electric energy used. W equals to P into T. Using values we get 3250 into 4, that is equal to 13,000 watt hours or 13 kilowatt hours. Cost of electric energy equals to rupees 4.50 into 13, that gives us rupees 58.50. We have to calculate the total number of units consumed in operating a 100-watt lamp for 5 hours, 500-watt electric iron for 3 hours, and 1 kilowatt heater for 4 hours. We also have to compute the cost of energy consumed at the rate of rupees 4.50 per unit. Let us first write down the given data. Energy cost per unit equals to rupees 4.50 for lamp load. Given power rating P1 equals to 100 watts and operating time T1 equals to 5 hours. Let us now calculate electric energy used by the lamp. W1 equals to P1 into T1. Using values we get 100 into 5, that is equal to 500 watt hours. For electric iron, given power rating P2 equals to 500 watts and operating time T2 equals to 3 hours. Let us now determine electric energy used by the iron. W2 equals to P2 into T2. Using values we get 500 into 3, that is equal to 1500 watt hours. For electric heater, given power rating P3 equals to 1 kilowatt, that is equal to 1000 watts, and operating time T3 equals to 4 hours. Electric energy used by the heater W3 equals to P3 into T3. Using values we get 1000 into 4, that is equal to 4000 watt hours. Now we shall calculate total electric energy used. W equals to W1 plus W2 plus W3. Using values we get 500 plus 1500 plus 4000, that is equal to 6000 watt hours or 6 kilowatt hours. Now we shall calculate cost of electric energy, that is equal to rupees 4.50 into 6, that gives us rupees 27. The details of electric load in a house are as follows. 3 lamps of 60 watt each operates for 5 hours per day. 2 fluorescent tubes of 40 watt each operates for 4 hours per day. 4 fans of 75 watt each operates for 10 hours per day. And 1 electric iron of 1 kilowatt for 2 hours per day. We have to determine the energy consumption and cost of energy consumed at the rate of rupees 5 per kilowatt hour for a month of 30 days. Let us jot down the given data. For lamp load, given number of units N1 equals to 3, power rating P1 equals to 60 watts, and operating time T1 equals to 5 hours. Let us now compute electric energy used by the lamps. W1 equals to N1 into P1 into T1. Using values we get 3 into 60 into 5, that is equal to 900 watt hours. For fluorescent tubes, given number of units N2 equals to 2, power rating P2 equals to 40 watts, and operating time T2 equals to 4 hours. Let us now determine electric energy used by the tubes. W2 equals to N2 into P2 into T2. Using values we get 2 into 40 into 4, that is equal to 320 watt hours. For fan load, given number of units N3 equals to 4, power rating P3 equals to 75 watts, and operating time T3 equals to 10 hours. Now we shall calculate electric energy used by the fans. W3 equals to N3 into P3 into T3. Using values we get 4 into 75 into 10, that is equal to 3000 watt hours. For electric iron, given number of units N4 equals to 1, power rating P4 equals to 1 kilowatt, that is equal to 1000 watts. Operating time T4 equals to 2 hours. Let us now determine electric energy used by the iron. W4 equals to N4 into P4 into T4. Using values we get 1 into 1000 into 2, that is equal to 2000 watt hours. Given energy cost per unit equals to rupees 5, we have obtained electric energy used by the lamps W1 equals to 900 watt hours. Electric energy used by the tubes W2 equals to 320 watt hours. Electric energy used by the fans W3 equals to 3000 watt hours. Electric energy used by the iron W4 equals to 2000 watt hours. Let us now calculate total electric energy used per day. W equals to W1 plus W2 plus W3 plus W4. Using values we get 900 plus 320 plus 3000 plus 2000. That gives us 6220 watt hours or 6.22 kilowatt hours. Since 1 month comprises of 30 days, total electric energy used per month equals to 30 into 6.22, that is equal to 186.6 kilowatt hours. Cost of electric energy per month equals to rupees 5 into 186.6, that is equal to rupees 933. So today we have solved a couple of simple numerical problems on basic concepts of electrical engineering. By solving these problems, we have learned how to determine the amount of energy in context to an electrical system and estimate the cost of energy. Hope this lecture has been useful for you. If you have any suggestion or question, please drop it in the comment section below. If you have liked this video, give it a thumbs up and share it with your friends. Thank you.